Good morning. I'm Akhila. I would be presenting NFV apps on Openstack, specifically with the use case of building verification sandboxes for NF network functions built on virtualized VNFs. So when we talk about virtualized network functions, a couple of things come to our mind. The first one is the orchestration, dealing with the various phases in the lifecycle management of the VNFs. The key phases are what you're seeing here. The first one is the onboarding phase, where you push in your templates onto your orchestrator. The orchestrator understands these templates, converts it into a metadata so that it has it stored in your internal structures, and it is ready to spin off your network service when a user requests for it. The second one is a deployment phase, which is the most complex because it has to do an interworking between the different components, likewise the orchestrator, the infrastructure manager, your virtual network function manager, and your virtual network functions themselves. During the deployment phase, it requests for infrastructure resources from a Vim like Openstack, and it requests the VNF manager to do the configuration once the virtual network functions are deployed and makes sure that the service has come up end to end. The next key aspect is the monitoring for various things, to monitor for faults or for failover or for scaling. And then the updation of the network service from the configuration perspective once your service has come up. And finally, decommissioning. So when we are talking about end-to-end service orchestration, these are the different things that we are referring to. To address these needs, we have, this is a reference architecture of a network service orchestrator and a VNF manager that we have built on OpenStack to deploy third-party VNFs. As I mentioned, the use case that we are looking at here is to spin up verification sandboxes. So you could have any virtual network function coming in from any vendor. The VNF manager that we have here is sort of a simple framework that runs inside a network namespace and communicates with your VNFs over L3. And for this specific scenario, we have some special requirements with respect to the orchestration. Likewise, when you spin up a network service, it doesn't happen quickly. It takes some time. And it is like you are trying to upload a file without a progress bar. So you're clueless until the activity completes, which is not the right way to work with this kind of environment. So what you would need here is an event framework which gives you continuous updates about what actually is happening in the background so that you are able to react to those events. And it's not just that. There is a lot of metadata that is generated as your network service gets deployed. This metadata is very useful because what happens in a network service is you have interdependencies. You might want to spin off your next network function depending on some parameters that you would extract from the previous deployment. So all this is possible through this metadata. In order to achieve this, we have built an event framework into this orchestrator. We have the OpenVNF manager on GitHub, and it is able to post these events via REST API. Now, why does it have to post these events? It can simply expose an API through which you query. In that case, what happens is you end up going in a loop and continuously querying because you do not know what is actually happening in the background. To avoid that, we are pushing in the updates to anyone who has subscribed to those particular resources. And using this metadata, without any hard coding or pre-configuration, you would be able to deploy your network service with the dynamic parameters. And the next important thing when you're talking about verifying the network service is to be able to provide proper diagnostics so that you're able to troubleshoot in case there is an error. For this, we had tried a couple of alternatives, likewise using Ansible to capture the network packets via TCP dump from the host interfaces. That is very bulky, it doesn't scale, and the data that you get is sort of late. It comes once the test case is completed, and so the correlation becomes difficult. So for this, we have used this feature called Tap as a Service in OpenStack, which gives a very nice API for you to be able to capture the network packets from the interfaces on the virtual network function. We have built a lightweight correlation engine based on DPDK, which lets you pick just the package that you want to show to the user so that he's able to derive meaningful conclusions from the information that you're showing it to him. And you're able to achieve proper diagnostics. It prevents you from having to run the whole scenario again when there is an error. So that is pretty much what I had to cover today. Thank you.